decision properties of the regular language. So any decision problem will be looking like this. So this is a decision problem solver. So where you will give some input, which will be some question, and the answer will be either yes or no. So it means that if you are given some statement here, so the output of this will be yes or no. So some example for the decision problems. So suppose given L, whether W is in L. So this is a decision problem because the answer will be either W belongs to the language or does not belongs to the language, which means thus the answer will be yes or no. So if this is a question, so how I can solve this problem? So first thing is for your L, build your DFA. Then input your W to the DFA. If your DFA ends in an accepting state, then the answer is yes, which means that this W belongs to the language, otherwise W does not belongs to the language. Next is emptiness test. So your L and empty. So the approach is again from the start construct your DFA for L, and from the start state run the reachability test, which returns success if there is at least one final state which is reachable from the start state and failure otherwise. So your L is equal to 5 only if the reachability test fails. So it means that there is no final state which can be reached from the start state, then only your L will be 5. So next is finiteness. Is your L finite or infinite? Means your language contains the finite set of strings or infinite set of strings. So again approach will be construct a DFA for L and remove all the states which are unreachable from the start state, because if any state is unreachable, then does not that will not introduce any strings which are obtained from that. And the second will be remove all the states which cannot lead to any accepting state. So these are the two steps for which for the DFA given you are supposed to do it. Next, after removal, check for the cycles in the resulting finite state. If L is finite, then there won't be any cycles. Otherwise, if your L is infinite, if you have a cycle. So let us see some one more approach is to build a regular expression and look for a clean closure. If your clean closure exists, it means it is infinite. If it is not existing, it means there is a finite language. So suppose we'll see the finite test example. So given this DFA, you want to check whether this DFA is finite or infinite. So here what are the two steps which are given? So you are going to remove this state, because this is an inaccessible state and this is a state which will not be reaching the final state from this state. So these two states I'll be removing. Then I have the cycle here. So here. So I don't have a cycle. So here in this case, after removing these two, we can see that there is only one path to the final state. There is only one way path to the final state, and from the final state you don't have any backward edges or the self loop. So it means the DFA is a finite state. Suppose another is this is a machine. So then you can observe here. So this is a state which I will remove here because it is not going to from this state there is no reachability to the final state. So this state I will remove, and from this again if you see that there is a self loop on this Q3, so which can be making the strings any number of ones can be generated from this. So this makes the DFA an infinite DFA. So thank you. Due to this it is infinite. Thank you.